What are the root causes of ice ages? Is there going to be another one? Since it had become generally recognized by the middle of the 19th century that a large portion of Europe had once been covered by a great sheet of ice, scientists have been wondering what could cause such vast shifts in the climate of the Earth. This question has been ongoing since the mid-19th century. Other people started hunting for astronomical reasons to explain what was going on. Hello everyone, and welcome to another video. Today we'll be looking at ice ages coming. This is what Milanković cycles will do to Earth. Yeah, you heard it right. They already know that the tilt of the Earth's axis was responsible for the change in seasons, and they also understand that slight shifts in the Earth's orbit, which occurred over the course of tens of thousands of years, altered the quantity of solar radiation that reached the Earth. There were a number of scientists who hypothesized the existence of a cycle of global winters. However, none of their calculations appeared to be accurate, and it was difficult to determine whether or not they could be trusted. Each theory was ultimately disregarded as irrelevant. Milanković, a young mathematician from Serbia, made the decision in 1911 to create a chart depicting the ice ages that occurred during the Pleistocene. The time period known as the Pleistocene began approximately 1.8 million years ago and lasted until approximately 11,500 years ago. It was marked by lengthy ice ages during which glaciers covered huge parts of the continents. These ice ages were separated by brief interglacial periods during which the climate was moderate. All of Milanković's computations were performed by hand, and he labored over them diligently over the course of the following 30 years. New knowledge concerning slight shifts in the inclination of the Earth's axis was factored in, and he also took into account the effect that the gravitational pull of other planets has on the orbit of the Earth. Each of these orbital fluctuations takes place according to its own timescale. As a result, their interactions with one another change over the course of time but remain consistent overall. As he did his calculations, he went back 600,000 years and he carefully estimated the influence that these things would have on the amount of solar radiation that would reach the northern hemisphere. The graphs and tabulations that Milanković developed are in widespread usage even now. He also analyzed summer solar radiation curves at high northern latitudes, which is where the glaciers that formed throughout the ice ages started. By doing so, he was able to link particular low points with the four preceding European Pleistocene ice ages. The astronomer and mathematician did their research and came up with an exhaustive explanation for glaciation. Milanković came to the conclusion that the Earth's orbit goes through three different cycles of varying lengths as a result of his investigation, each approximately 96,000 years. The geometry of the Earth's orbit around the Sun shifts from being less elliptical to being more elliptical and then back to being less elliptical. At this point in time, the axis of rotation of the Earth is skewed at an angle of 23.5 degrees with respect to the plane of the Sun. But in around 41,000 years, this tilt will change from 21.5 degrees to 24.5 degrees and then back again. The axis of rotation of the Earth also has a period of 23,000 years during which it wobbles. Milanković faced a number of obstacles in his attempt to comprehend when the three cycles were in phase with one another and how they interacted with one another to have an effect on insolation, which is the amount of solar radiation received by the Earth. Milanković postulated, on the basis of his estimations, that the amount of sunlight that reaches northern latitudes varies by more than 20% at different times of the year. He stated that this was the source of the waxing and waning of the huge continental ice sheets in his report that was published in 1941 entitled Canon of Isolation and the Ice Age Problem. The work of Milanković, like that of a number of other predecessors, was first met with a great deal of excitement but was eventually largely disregarded. Ice ages are notoriously difficult to date, in part because each one tends to leave behind little signs of the one that came before it. By the late 1960s, however, the situation had completely reversed itself. Geologists now have the ability, thanks to advancements in technology, to examine deep-sea sediment cores that carry a climatic record stretching back millions of years. This temperature record reveals astonishingly regular changes which match the mathematician's calculations and are now referred to as Milanković cycles. These cycles have been named after the scientists who discovered them. On the other hand, it is abundantly obvious that celestial influences cannot be solely responsible for the massive changes that the Earth went through. The climate must also be affected by other variables, but scientists do not yet understand how this happens. So that's all from today's video. If you enjoyed it, remember to leave a like, subscribe, and ring that bell icon so that you never miss our upcoming videos. And don't forget to share your thoughts in the comments section down below. Stay tuned, and we'll catch you in the next video.